Hello and welcome to Math, Minecraft and Computers, episode I29, Øyhus Advantage. In this episode we're going to build a circuit that is designed by somebody far smarter than me. And it's a 16-digit hexadecimal display. One time I was researching how to create a better optimized hexadecimal 7-segment display when I came across this image. Now this is showing a circuit that is designed to use 30 NAND gates, which is actually a pretty amazing number for a full hexadecimal display, and I was very skeptical. But that did lead me to going to this page. And this page actually shows right here, when you click on this link, the design for the same circuit. And so I contacted the designer of the circuit, and his name is Kim Øyhus. I'm probably getting that name wrong, and for that I apologize. I have never learned Norwegian, so I'm not good at pronouncing that, but we're going to go with Øyhus and hope that is close enough. And he designed this for a circuit contest, a circuit design contest, and actually came up with this, and this, I got to tell you, is a pretty amazing circuit. This is only 30 gates. If you recall the difference between our circuit, this circuit uses only 2 input gates, and since we needed 16 different selection gates, if we used only 2 circuits, it would take 48 gates just for us to select the different 16 signals. So that alone already puts our circuit far above this. I had done some work on my own one time, came up with an evolutionary algorithm to try to find my own optimized for this, and I topped out at 42 different gates using my evolutionary algorithm, which took 8 months to run. So I was quite surprised when I saw this, and I have to say I was skeptical. So of course the first thing I did is I put it in Logisim. And here it is in Logisim. You can see that it is set up here. So what I did is I simply took the original diagram that I received, which is a pencil and pen drawing, believe it or not, of this circuit design. And you can see over here it has the inputs of the bit 0 through 3 from the bus. And then there's the different NAND gates that are this way. And then you can see that at various points, as I'll go ahead and send mode, and you can see where these are connected in to the circuit. For instance, one comes out of 17, you see segment G comes directly out of gate 17, which is further back here in the circuit. So it seems like a fairly random design, and I'm assuming that Mr. Øyhus has written some sort of program or some sort of simulator to help him come up with this, because it's fairly random to determine how this works. Now, it's easy to reverse engineer now that I have the circuit, but it still doesn't make sense on how you would go forward. So I have to tell you that it's absolutely brilliant, and this is absolutely an amazing circuit that has come from somebody that really knows their stuff in this. Very impressive, but does it work? Let's go through them. We're currently at 0, sure enough, 1 and 2 and 3. So we have the first 4 states good. There's the 4 and the 5, the 6 and the 7. Everything is good there. The 8, the 9, the A, the B, the C, the D, the E, and of course the F. So there you have it. A working hexadecimal display in only 30 gates on a 7-segment output. Very, very impressive. Now, I've got this designed. I've actually got it spaced out so that we can translate this directly to Minecraft, which would be, of course, my contribution to this is can we do this in Minecraft, and can we make it small? So the way you have to optimize the circuit in Minecraft takes a decent amount of work. I started with graph paper, and I directly translated this to a Minecraft design, which you can see here. Pretty large. Now I've got in this red is 1 up, yellow is 2 up, yellow with a red stripe is 3 up, and then of course green is down 1 and blue is down 2. And so if you look at this circuit, you can see exactly the same gates that we have. Here's the Logisim circuit of the Øyhus display. And here is the planned, hopefully working Minecraft circuit that I converted to in Minecraft. So our goal in I29 is to do two things. The first thing we want to do is review exactly how is it we build an AND gate as a review. And the second thing is, let's actually build a circuit in Minecraft and see what we come up with. First thing that we'll do is we'll review an AND gate. So we're going to put down a sign right here that says, this is an AND gate. We know exactly how to create it. We've done many of these, so this shouldn't be a problem. It is, of course, 3 blocks, 2 torches, and some redstone wire. The other thing we need for an AND gate is a torch here and there. Let's put on a couple of switches for this too. So now this should only come on when we have both inputs on and only on. And so there we have it. We'll look over here. I can add a lamp, make sure that we can see that clearly. And so this is a AND. Only if both inputs are on, it doesn't matter. Okay, how do we change this? Well, you look at this design, you've got one of the inverters here, one of the inverters here, and we have another inverter here. So this is actually inverting the signal out of the AND gate. If we just replace that with a piece of wire, we get exactly the opposite. It says only if both are on. Then our light goes out in the state that only both are on. Anytime that they're both off, anytime that either one, we have it on, only when they are both on do we want the circuit off. And so that is exactly how we create the AND gate. Now create a multi-input NAND gate. Only if all 3 of these are on will that light come on back there, just like that. Now you would say, well, perhaps to create a multi-level NAND gate, I just need to remove this and hook this up, and let's see if it works. Only when they're all off should it go off, and look at that. So creating a multi-NAND, input NAND, is exactly the same. You see I can do any combination of any 2 gates that I want, and only if they are all on does it go off. So there's a 2-input NAND gate, and this is a multi-input NAND gate. The same is the same. It's the same as doing an AND. We only take the inverting torch off AND. All right, let's get busy on this circuit. Okay, here we are at our hexadecimal circuit that we built before. You can see ours are 16 input gates that are 4 gates, inputs each. These select one of the 16 possibilities that are then ORed together in these gates, and they all come back to the 7 segments. Now we want to do the same thing. We want to drive the same. Now the first thing you'll notice, if we look at the Øyhus design, is you see that we don't need anything but the bits themselves. We don't need the inverted over here. So what we can do is bit 3, bit 2, bit 1, and bit 0 here. That's how we'll actually end up doing this with his design. We don't need anything else. But let's go back and look at my Minecraft design. You can see that it is 23 by 75. So 75 from left to right, which will be in this direction in Minecraft, and there's 23 in this one. And because I'm going to need to do a lot of counting to make sure I get things in the right place to match my design, I'm going to show you a trick that you can use. So we're going to build it about starting right, let's say, here. So I'm going to trade this in for a yellow. Terracotta, you can go with concrete. I'm going to stick with concrete, put it here, and we're going to go every other down this way. Now we have to do this with 75, so it's very easy. Every 2 we go starting right there. There's 2, 4, 6, 8, 10. So every one of these that we put down is going to be 2. Let me get that done and we'll be back. To make our checkerboard, we actually want it to come to this location, and we want to start filling it in like this. That way it makes it very easy to count. You can simply count by going 1, 2, 3, 4, etc. to find out where we want to put things, but I don't want to actually build that myself, so there's a very simple way to do that. Let me replace this really quickly. Let's get our coordinates here for this block moving in that direction. So as you can see, the block that are targeted is 139, 14, 107. You can see that, and then we're copying in this direction. We want to go 75 blocks, and that way I'm going to do 80 to make that easily, that our destination is going to be, our source is here, the end block is going to be way down there, which is going to be 139, 14, 188 in that direction. That gives us 80. This is where we want to put it. If we put it here, they line up. We put it there as our target block. So our clone command becomes starting at the starting block of 139, 14, 107. We want to end at 139, 14, 187. That's 80 blocks forward. Now we want to put this at our current target blockage, which is 138. We want to keep the same up and down, which is Z. And then we want to go with, where do we want to put this? Same way. The block we're pointing at 108. And there we go. So now all I have to do is simply go back and forth between this. Where do you want to move this? I'm going to put this at 137 and 107, and we get this. And so you just go back and forth. This is going to be an 8, and this is going to be a 5. Missed that. It's going to be a 6. And then a 7 and a 5 and so forth. So I will continue to finish this, and we'll be done. There we go. You can see we now have a checkerboard that will let us count things on very quickly. And so then it becomes time to build this circuit. Now we can put this in after we're done, so it's just a matter now of using this Minecraft map that I have right here and following it along exactly to get it to fit in this space that I have delineated with this checkerboard, to make it very easy to transfer from my graph paper design to the world of Minecraft. So here we go. Let's take the Øyhus Advantage and let's build the most advanced hexadecimal display for the 7 segment that I have ever seen in Minecraft, and see what we come up with. So I've created the first gate and set it here in its position. It's going to be important for us to have this in the right place because there's a lot of counting. I need to make sure I can count spaces to get my circuit exactly like it is in my design on the graph paper. So I've set the inputs over here. You can see that I've already got them set up according to our map. And now it's just a matter of actually building the rest of the gates. And so here they are, inputs 0 through bits 0 through 3 that you see here. And then we start building our gates. I put our first gate right here. This is gate 1. And the way I'm going to build these is I'm going to connect them up only as I get done. So we're going to put this here, and this will go here like so. And I'm going to label them only with the number of the gate in both inputs, only when complete. There will be points where I'm actually connecting gates in advance, and those points I'll just put the number of the gate on, but this is the way I'll do it. So on the left side, I'll go ahead and I'll put the input from the left side. So in this case, you can see that it's B0. And then this symbol to show on the right side, it's also B0. So since this gate is a NAND gate that connects both of them, actually what this turns into is an inverter and universal logic, but we'll talk about that later. And then from here, I'm going to start building the other gates. Now the first thing that we need to do, of course, is that I'm going to space out gate number 2 and find where it goes. You can see on our map it's 10, so I need to count 10 forward, and that's simply going by 2s, and it goes right here. So that is gate 2. I connected up here with some redstone. Go ahead and build the gate mechanics itself with the torches and the wire. And then we're going to connect it and label it as well. Now it's already connected, I had already done that. It's just a matter of connecting to the inputs. And you can see with gate 2, our 2 inputs are actually bit 0 again and bit 2. So we need to make sure we have this in bit 0 and bit 2. And so we put the gate number, and then we put the left connection, which is bit 0, and the right connection, which is bit 2. You can see this comes back to there's bit 2, and of course underneath going along here, you can see that wire goes to bit 0. So we're all set there. So now it's a matter of counting spaces over here on the graph that I drew, and making sure that all the gates are in the correct places. Because we want the circuit to be the same everywhere and to maintain its speed, it's going to be important that I get everything spaced out correctly. So there's going to be a lot of counting, and of course there's no reason that you want to watch this step by step. So I think this is a good time to go ahead and speed up what we're doing and get this work done. And so from here, you can see that we go out and we start building off in this direction, finding out where gate 1 connects to, which is going to be gate 3, which will be our next target, and then off we go. Once again, I will only put the complete full sign label on the gate once it's built. Other than that, I may put the number. It's very easy to just tack the number up real quick when I'm building so that I know where I'm going. And then as I do that, it'll also help me line up and find any mistakes that I've made. Now keep in mind the circuit builds both in an upward direction and a downward direction in 2. You can see back on our graph paper that we have everything we need to get this done. That red is up 1, yellow is up 2, yellow with a red stripe is up 3, down 1 is green, and down 2 is blue. That's the numbers count, and you can see on our map that I come over 3, and then out 3 from the gate, and then over, and I continue to do that to build this according to this map that I have here. So you can see that 1 is going to go over to gate 3 in this direction, and then it connects here, and you can see that that is then gate 3. And 1 also is going to go down the other side, but this is what I'll show you. Here's where I'm actually going to put the sign that indicates this gate 3 right here. Now we're trying to connect all the gates in a forward direction as much as I can, but the way I'm going to do the signs will at least verify. When I come and connect the other side, I'll label that. And then you can see the gate 1 is going to need to come down over on this right side. So that is it, and it's time to go high speed, and we will see you soon. a 7-segment display here that we can use. It's the standard one that we've been using. And I've also wired it into our new circuit that we have. For instance, here you see gate G, or segment G, comes off of 21 here. If you recall, it's over here. Okay, so I have built a 7-segment display here and wired it into the Øyhus circuit that we built earlier for the 7-segment display hexadecimal display driver. And for instance, you can see, for instance, G, as you recall, segment G comes off of gate 17, and so there you can see that it is wired into G right there. So all of these have come from their respective gates in the circuit design, connected to the 7-segment display, and now we can test it. So I'll come over here. Here are the inputs. Bit 0, bit 1 is here, bit 2 and bit 3. You can see that the current is set for 0, so we'll go through them. That's the 1. There's the 2. The 3. Four. 5, 6, you just saw the 7 that was still in the line, and of course to do the 8, we can just switch all of these off. There's the 8, the 9, the A for 10, the B for 11, the C for 12, the D for 13, the E for 14, and finally the F for 15. So there you have it. You'll notice that the circuit is much faster. I'll come over here real quick and we'll change very quickly, say from the F to 8 by clicking, clicking, and clicking. You can see the circuit moving. There you can see how long it took. We're going to do the same thing over here, just for a reference. Off. Off. It was already there before I could even click on the next one, then off, and we're done. So this is a much shorter circuit and much less circuitry, only 30 gates required. You can see that this is just even the distance of this larger circuit over here compared to the 2. There you have the difference in size. This circuit starts from right here, goes to there, all the way back to this corner. That's all required for the circuit. Here you can see the difference is starting right here, goes to there, and ends right there. So that is all the circuit. Now the last part that we can do, as I will show you later, is we can get rid of our checkerboard that we created to help us create this circuit. But that'll be for another lesson. So that concludes our I29. The super brilliant, absolutely amazing Øyhus 7-segment hexadecimal display designed by Kim Øyhus. Been an amazing build and very actually privileged to be able to build such an incredible circuit. Minimal 30 gates to drive a 7-segment hexadecimal display is pretty darn amazing. It's been my privilege to do it. I hope you guys learned something. Keep on learning. This is M. Roy, Minecraft Computers I29, out.